Hi, in this video we are going to solve a few problems from section 2.6 and 3.1 for the assignments. The first one is question 10 from 2.6. So this question gives you the equation in the standard form. Okay, the standard form means x and y, they are on the left side and the number is on the right side. Now for this question, they ask you to find the x and y intercept. Now to find the y-intercept, we let x to be 0 and we solve for y. Okay, so that's why the question already set you x to be 0 and now you just solve for y. So we get the equation, we get back the equation. So anywhere you see x, now it's become 0 because you let x to be 0 and we solve for y. Right, so x is 0 and we just solve for y. We know that this is 0 because 3 times 0 is 0, so y equal minus 1. For the x-intercept, again, we let y to be 0, we solve for x. So the same thing here, anywhere you see y, now it's become 0. Sorry, this should be 1. Okay, so this is minus 1. So anywhere you see x, oh sorry, anywhere you see y, because y is 0. Anywhere you see y, that becomes 0. And then I'm solving for x, so minus 3x equal minus 1. So divide both sides by minus 3. You solve for x. Minus cancel out, so you get plus. Okay, so 1 over 3. Just to find the y-intercept, we let x to be 0, we solve for y. To solve the x-intercept, you let y to be 0, we solve for x. And then you just want to rewrite this equation in the slope-intercept form. The slope-intercept form is when you have y equal mx plus b, where m is the slope, b is the y-intercept. So now to solve, all you do now is you solve for y from the standard form. So it's very simple. 3x plus y equal minus 1. So I add 3x on both sides so that I can take away the x on the left side. Now on my left side I only have y equal, on the right side now it's 3x minus 1, and that is the equation in the mx plus b. Now the last one is when you check if this is a solution to the equation. If this is a solution, means when you plug in this point to the equation, it makes the left and the right side to be equal. So this is the value for x, this is the value for y, this is the order pair. So you get back the equation minus 3, anywhere you see x, you plug in 2. Plus y, anywhere you see y, plug in minus 2. And are they equal to the right side? So minus 3 times 2 is minus 6. Minus 6 minus 2, that is minus 8. Minus 8 and minus 1, they are not equal. So the answer here is no. This point is not a solution to the given linear equation. Okay. The next question is from chapter 3.1. 3.1. Question 8. Okay, so we are asked to solve the system either by the addition or substitution methods. Okay, so we can use either the addition or the substitution methods. Now, don't forget that the addition is the same thing as the elimination method that we learned in the class. Okay, so in this case, well, maybe I can use the addition or the elimination methods. Now, to use this one, you have to find a number that you multiply to the top equation so that the x is become minus 4x because you want to cancel one of the terms. So I want to try to get rid of the x. So I see that I want the top equation to have minus 4x. So I have to multiply by minus 4 to the whole thing. So if I multiply by minus 4, I multiply to all of them. Minus 4 times x is minus 4x. Minus 4 times 5 is minus 20y. Minus times minus become plus. 4 times 10, that is 40. And then I keep my second equation. And now we use addition. That means we add them together. Another word for the elimination methods. So I add them together. You can see here minus 4x and plus 4x, they have the opposite side and the same amount of 4. So you take away the x term. So minus 20y plus 1y, that is minus 19y. 40 plus 9 is 49. Right? 40 plus 9 is 49. And to solve for y, divide both sides by minus 19. Minus 19. So you take away the minus 19. Then your y should equal to 49 over minus 19. Can we simplify 49 and 19? It looks like they don't have any common factor, right? So that's the answer for y. So y is 49 over 19. You can place the minus here. Doesn't matter, right? Top of the bottom, the same thing. And then once you get y, you have to solve for x. Okay, so I have to solve for x. So let's try to solve for x using maybe the first equation. So I just rewrite the first equation. X plus 5y equal minus 10. I know y, so I can plug in y to here. So x plus 5. Now instead of writing y, we know y is minus 49 over 19. And then equal minus 10. And then you have to solve for x. Now you have to simplify it before you solve for x. So 5 multiplied, this is a minus, so you have minus here. 5 times 49, 5 times 49 is 245 over 19 at the bottom, equal minus 10. So to solve for x, I have to add, let me write this one. I have to add 245 over 19 on both sides, right? 245 over 19 on both sides. I have to add that because I want to solve for x on the left side. So this is gone. So x is equal to 249 over 19 minus 10 on the right side. And if you do the subtraction, 245 over 19 minus 10, the answer for x should be 55 over 19. If you do the addition of the fraction here, so the answer for x should be 55 over 19. Okay, so that's the answer. Okay, let's see the next question. The next question, okay, let's test the answer here to make sure we get it correctly. 55 over 19, and then the y should be minus 49 over 19. Minus 49 over 19. Okay, submit. Okay. The next question is 3.1, the same section, but this is question 9. Solve the system by using, again, the addition or the substitution methods. Now choose the method that is the most appropriate to solve the problem. Okay, in this case, anytime that you see there are fractions, again, we have to simplify the fraction before we can do anything else, because it's very difficult to work with fractions. So again, to simplify the fraction, I must multiply the whole equation by the LCD, right? In this case, we see that this is number 8, number 6, number 3, What is the LCD for that? What is the number that you can divide all 8, 6, and 3? So 8 times 2 is 16. You cannot divide by these twos. How about 24? Yes. 24 can divide by 8, by 6, and also by 3. Okay. So I multiply 24. I multiply 24. So make sure I do the distribution to all of them. So 24 go to the first terms, right? Multiply. Keep the minus sign. 24 go to the second term. Multiply with 16y. And then 24 go to the last term on the right side. And we can see that 24 divided by 8, that is 3x. 24 divided by 6, that is 4y. 24 divided by 3, that is 8. It's very simple now, right? Without fractions. The same thing we do to the bottom. 6, 3, and 4. The LCD should be 12. Because 12 can divide by 6, by 3, and by 4 together. So we do the distribution of 12 to each of them. So 12 go to the first one, multiplication. We keep the minus sign. 12 go to the second one. We also keep the multiplication here. And then 12 go to the last one. Okay. 12 divided by 6 give me 2x. 12 divided by 3 give me 4. Make sure we still have the minus sign. And then 12 divided by 4 give me 3. Okay. Okay, in this case, which one should I use? Substitution or addition or elimination? Well, we can see if you have to use the substitution, you have to solve for x or y in this case for one of the equation, and then use that to plug into the other equation. And again, if you solve for x or y, you have to move things around and then divide by the coefficient, and then you get fraction again. So I don't like that. Maybe we can go with the elimination or addition. Well, we already see that there's a minus 4y. There's minus 4y. So somehow we have to make one of them to be plus 4y, so that we can add them together and the y term gone, right? So I can multiply the whole bottom equation by minus 1. So minus 1 go here, and then go here. So let's do that. I should have minus 1 2x minus 2x, minus 2 minus become plus 4y, minus 2 3 give me minus 3, and then I just rewrite the first equation equal 8. And now we use the addition. That means we add them together. 3x plus minus 2x give me 1x. The y minus 4y plus 4y, they are gone. 8 plus minus 3 give me plus 5. So x, the answer is just 5, right? Now once you get x, you can use one of the two equations here, and we solve for y. Let's just still use the first equation. So 3x minus 4y equal 8, but now your x is 5. So anywhere I see x now become 5. And then minus 4y equal 8. This is 15 minus 4y equal 8. And I subtract 15 on both sides. So I get minus 4y. And then the right side, 8 minus 15, that should be minus 7. And then to solve for y, we divide both sides by minus 4. Minus 4, so the minus 4 are gone. On the left side, y equal minus divided by minus become plus 7 over 4. And there's nothing we can do with 7 over 4. So the answer is y equals 7 over 4. So the x should be 5 and the y should be 7 over 4. Okay, so that's the answer for this problem. The next one is again the same section, 3.1, and this is question 10. Okay, let me open a similar question. Yeah, same question, but different numbers here. So suppose that the average cost of electricity is $0.15 or 15 cents for per kilowatt hours. Now the solar panels cost 100 per square feet, and you want to install 300 square feet of solar panels. Assuming that each square foot of solar panels produce 20 kilowatt hour every year, and further assuming that the government tax they are paying for 50% of the initial cost. Now round the answer to 2 decimal places. A. Find the cost to install the 300 square feet of solar panels. And remember to reduce the cost for the government tax incentive. Okay, we know that it takes you $100 for 1 square foot, right? So the solar panel costs $100 per square foot. Now you want to install 300 square feet. So all you do now, you multiply by 300 by 100, which is 30,000. So 30,000 is needed to get the 300 square feet. Okay. However, we know that the government tax will pay you back 50% of this amount of money. So all you have to pay is 50% of the full amount, or the cost to install the 300 square feet should be 50% multiplied with 30,000 K, or 0.5. Make sure that 50% is 0.5 in decimal and multiply that with 30,000. You should pay only half of the price of 15K, $15,000. Okay, now find a function for the amount of money saved by using the solar panels, where T represents the number of the years. Okay, so now we know that you want to find the amount of money that you can save from using the solar panels instead of using just the regular electricity. Now remember that once you install the solar, you don't need to pay anymore for the electricity that the solar panels make for every year. This is all natural resources. So whatever the solar panels make in 1 year is all the free money that you pay before. Okay, so we know that 1 square foot of solar panels will produce 20 kilowatt hour for each year. Okay, from here, 1 square foot of solar panel produce 20 kilowatt hour each year, and we install 300 square feet. So the total amount of kilowatt hour that the 300 square feet solar panels make is 300 multiplied by 20 for each year. That the total is 6,000 kilowatt hour per year. This number is the number of kilowatt hour per year that your solar panel produce, and this is for 1 year. And we assume that the average cost of electricity is $0.15 or 15 cents per kilowatt hour. So this is how much you produce each year, and you take this kilowatt hour multiplied by the cost. Therefore, the total cost for this much free of solar panel of 6,000 should be 6,000 multiplied by 15 cents. So $900 for 1 year. Okay, so this is the amount of money that you have to pay if you are using the normal electricity. But now, because we are all using solar panel, you don't have to pay anything. That means we are saving $900 for a year. This is the profits that we make from solar panels. So we don't have to pay anything. If I assume that you use the normal electricity, then you have to pay this much money for 1 year. Okay, so how do I write a function of money that I save by using the solar panel? Well, that is a function with this profit. So $900 is the amount of money for 1 year that I save for using the solar panel. So I multiply that by T, because T is the number of the year that I count, right? And then make sure that subtract the $15,000. the reason that we subtract $15,000 because this is the installation fee from part A. Now, even though we gain some profits, but we need to spend some investment in the beginning to install the system. Okay, so you need to subtract it from the profits you make just one time. You just need to subtract it one time only, because you spend this much money to build a system, and this is the profit. The gaining for each year, $900 per year multiplied by T, but you still have to subtract to the cost that you use to install the whole system. Now, we need this function for part C. They ask you to find the break and even points for the solar panels pay off their original cost. Now, this asks you how many years after you start using the solar panels, then you will gain enough the amount of money from the system that equal to the installation cost you pay in the beginning. Well, we know that the installation fee is $15,000, and the amount of the money you gain from using this system is $900 per year. So 900 T for T years. We want to set these two quantities equal to one another and solve for the time T. Right? So because this is the profits, this is the gaining of the amount of money from using the solar panel, but this is the initial cost. So we have to solve, set them equal to one another, and solve for T, 16.67. So this tells me that I will need to use the system for 16.67 years to gain the free 15,000 electricity bill, and then from there, after that, I will start really making the profits from using the system. Because don't forget that we have to pay something in the beginning to build up the system, and that was 15K. So you have to actually spend 16.67 years of using the solar panel, and then instead of paying $900 per year, in those 16.67 years, you actually get to $15,000, and that is the time that you actually get enough of the money that equal to the amount of money that you pay in the beginning, and then from after that time, around 17 years. So after 17 years, then all the using of the solar panel every year is your the money that you actually gaining. Okay, so that's the question for this one, 3.1, question 10. And then the next one should be 11. Okay. So this question, they give you the data for two models of a certain car, assuming gas is $1 per gallon. Now the first one, they ask you to find the cost function for each car. Okay, as a function of the mile driven X. Okay, so you want to find the cost of the function for each car. Remember that each car, for example, the hybrid one, the cost function, the cost is equal to the base price. This is the price that you have to pay for the car. So it should be 23,200. This is the fixed price. You have to pay for the car first before you can use it. And then the cost per mile, right? So each mile that you are using the car, it costs you 10 cents. So 10 cents for X, C of X is the function with respect to the X, and X is the mile that you drive. So for each of X, each mile X, you have to pay $0.10 or 0.10x. And then for the standard car, well, again, you have to pay something in the beginning to buy the car. So this is the fixed price. And then for each mile that you are driving, you have to pay 0.13x, and x is the number of the miles. Okay, this is the function of the miles. Now this is the cost for the hybrid. This is for the standard car. and they ask you to determine the break-even miles. Okay, so you have to set the two cost function to equal, and then we solve for the mile. So let's put them to be equal here. Set them to be equal. So I set the hybrid car, the cost of the hybrid car, equal to the cost of the standard car, 13x. Now I have to subtract. Let's solve for x. So let's subtract 19,200 on both sides. So 23,200 on the left side. Subtract 19,200 on the right side. Subtract that. I get 4,000 on the right side, and plus 0.10x equals 0.13x. Now subtract 0.10x, subtract 0.10x. So 0.13 subtract 0.10 or 0.1. It should give me 0.03x on the right side, equal to 4,000. And then to solve for x, divide by 0.03 on both sides. So 4,000 divided by 0.03, that give me 133.30. Two decimal places 33. Okay, so this is the number of the miles, to break the even point. Okay. All right, so that is how you find the break and even point for the hybrid and the standard. You want the cost of them to be equal. So that means you have to use this much of miles in order for the cost of the two cars to be the same thing again. Okay, so that is the end of this video to help you on some questions about section 3.1 and 2.6. And thanks for watching.